Hi, welcome to Parametric House. In this tutorial, I want to show you how you can make this parametric Voronoi structure in Grasshopper using a series of clusters. All of these can be baked. So we have them separately in different groups, which is going to be great for giving different layers. But as you can see here, you can convert that into a solid and create the final results. So as you can see here, we can change the number of Voronoi cells here and randomize them. We can control how many of these percentage can be columns. If we put that to 100%, it's going to be all columns. And also you can make a seed for that to change the location of the columns. After that, you can control the top part, which is this one. And as you can see here, this is going to affect the column 2. We'll put that to here. The next part is this one, which is the parameter of the tapering of the columns and also some height. We'll control that. You can also taper the columns, something like this. And there are some simple ways of just giving this some extrusion at the top, at the bottom for the columns. As you can see, you can taper that too and define the height of the spaces. Let me explain the logic here, which is really easy. Before we go forward, any of these layers can be baked in different layers if you want to. So for example, this one is bake that into layer 1. And the green one can be baked into layer 2. And as you can see here, they are in different layers. Okay, so remember that everything, every part can be baked in different layers. Let's take a look at the clusters and how this can work. So let's take a look at the algorithm. I'm going to turn off everything and also these previews. First of all, we have a curve input, which is going to be a rectangle. As you can see here, I can give any rectangle to the input. Let's just bring this a little bit up and set this to the curve. After that, I'm going to create a series of Voronoi cells using mesh triangulation and Voronoi. And to create the Voronoi, I've used the vector grid applet 2D. For that, you can just simply define how many points, random points you want, and also the random location by changing the seed. That is going to give you the points. The radius can be dismissed here. For the B, I've used the boundary, which is the same as the rectangle. So here you can see by changing that, that's going to update the final results. Okay, increasing the number of cells is going to increase the Voronoi cells. After that, I've created a cluster, which you can open and take a look at it. It's not really complicated, but it's going to help you to bring geometry into two groups of true and falses. So this is a really simple tool. You give any geometry you want. You can give curves, solids, or whatever. And as you can see here, it's going to give you two groups. Let me just connect a surface to that. And this is the percentage. The percentage can be 0, which is going to be 0 for the group 2 and 100% for group 1. Or you can just put that to 100%. Obviously, this one is going to be completely as an output, but this one is without any outputs. Again, you can change the seed to create different results. And now you can see that we have two groups. Let's take a look at this one, which is the top tapering. And I think that it's going to go for here. So I'm going to turn on the preview and explain how it works. Again, we have a cluster here. This cluster is not really complicated, but what it does is it gets a polyline, and you can define a parameter, which I'm going to explain. But before that, I've brought up the cells from the true false here. Then I've used the curve utility, and there's an offset by points tool, which is really great. What it does here is, let me show you. Assume that we give a cell to this. I'm going to bake the cells and bring one of these out so you can understand it. I'm going to give the polyline to it. And this is a number between 0 and 1. Obviously, a 0 is going to be the complete polyline and 1 is going to be at the center. You can actually do that by also using a scale, a transform scale. And for example, let's go and use the center of polygons, different centers. I think the center of edge is going to be fine. And let's get that to the factor. I think that I have to make this 1 minus x to make it similar to the output. So you can see it's actually a scaling of the polyline, but obviously it's easier to use because you just have to plug the polyline here and give it a number. So it moves these points, gets the center, and moves them towards the center of edges. That's how it works. So now that we have created these cells, I'm going to select everything, delete that. And this is going to be the border of the top part of the roof. So we can control that here. After creating this, I've made a cluster which can taper and actually move in the Z or opposite direction. This is a true false, which is going to flip the direction if you want to extrude it in the Z direction. A parameter which is going to, a 0 is going to be a simple extrusion. Going to 1 is going to be somehow near a point. But obviously, if you want to extrude to a point, you can use the surface freeform extrude to point. And then a Z extrusion. So it's actually like a taper component. We can use that here. And this is going to be the solids. If I bake that, you can see that we have the solids here. Let's move them around. So you can see that this is the final part. Okay. Now that I have this, I'm going to also use these two polylines to connect them together. You can use the surface freeform ruled surface to connect them together, and a simple extrusion up will give you this one. You can control the extrusion of that. And because I've brought this up here, I'm going to turn on this preview, and we're good. We are good to go. We can have that as the parts of the cells that we want to give some border to that. Okay, for the columns, this was for the parts that don't have any columns. So we have to switch to the group B of this geometry 2. So now that we have the second part of the cells, the first part is finished. We have them tapered. If you don't want to taper them, you can just control the inputs. But the second part is, again, another offset. It's the same as the first group. So you can see that we have this part. Again, we've brought it up here and some extrusion to give it for the top part. I can just turn on this one. So that's the top part, not really that important. The most important part is the column. So again, we have this tapering thing. If you want to see the preview, you just select that and turn this on. Okay. And this is the parameter you can control. You can see that's going to also affect the cells that don't have any column. But anyway, the height is also same. So we've used the same number sliders for the parameter and the Z move. And obviously flipping this is going to go and bring it upwards. Not really what we want, but use this flip if you want to change it in the Z or minus Z direction. Anyway, after creating that, the good thing about this cluster is that it's going to give you also the polyline of the bottom. So it gets a polyline, moves it down, taper, and again, it gives you the polyline here. Again, we give that to the cluster and create the columns. So I can just turn this on. And for this one, what I have done here is the most important one is the Z, which is the columns, the total height. For the total height, I've projected the complete rectangle on the ground. The centers are being calculated here. And then we've found the distance between them. So this is the distance and this is the total height we will have here. So after creating the height, what we want to do is to simply minus that by 2 inputs. One is the height of these parts, and another one is the height of the columns that are sitting on. So this is the height of the column sitting. So we've brought that to the minus. You can simply use minus here and add any number you want to the minus subtraction component and give that to the Z move. Okay, the good thing about this is that you can also taper the columns somehow if you want to. This is going to be very effective of the columns. So we can just put that here and control what we want. Again, remember that the randomize here for the cluster percentage can change the outputs easily. Okay. Maybe just 4 columns of 4 corners somehow like this is going to be fine. After creating this part that we talked about, and the second part again is the cluster from the polyline. Obviously, it's the polyline at the bottom. We've used that again to taper that. As you can see here, flipping it's going to go upwards, which we don't want. We brought that polyline from the bottom of the cluster here. We offset that by points. This time I've made an expression minus x to bring it outwards. So you can bring that outwards. And finally, we can use another cluster to create those solids for the bottom part. And we can turn this on. Okay, for the bottom parts, again, I've projected all of those cells down on the ground, XY plane. And again, use the same number of percentages and seed to create geometry 1 and geometry 2. That's obviously the same as the top for the cells that we want. So for the first group, we again cluster them to extrude that up and turn this on. We can play around. I've used the 0 because I didn't want to taper it, but you can play around with that too, just a simple extrusion. But if you give a number here, you can see that that's going to taper. And even if you want to, you can flip this one, obviously, upwards somehow, if you want to see what happens. So that is just like a way you can play around with this flipping thing. But I wanted to extrude it downwards. So just for more visualization, that is going to also happen for geometry 2 with this visualization, and the algorithm is finished. And you can use that to create your algorithm. If you want to create your own algorithm without randomizing it, what you have to do here is to control these curves. So actually, for example, let's say that we want to make an array of that, maybe 4 to 3. Maybe we have these grid cells, okay? So if you want to change that, what you have to do is to select the ones that you want to use as columns, or these ones as the columns. Use the shift key to add them up. And here you can see that. Obviously, we have to bring them up so they snap to the ground. You can see that's going to happen here. And then you can just flip and project these curves here. So we can just say another projection from these curves to the group polyline 1, and another one for this one for polyline 2 to make it like this. Just wanted to say that you can change the algorithm if you want to into a series of non-randomized cells. But anyway, this is the total algorithm. Maybe I think that's useful, especially for the clusters. You can use that. For clusters, you can simply just double click it and open and use it in your project. As you can see, it's really simple. And that's it. I hope that this tutorial was useful. If you have any question, ask below. See you next time. Bye.